All right. My name is John Ciovacco. I'm with Aztech Geothermal, and today I want to talk to you some about heat pumps' role in the inevitable switch or shift to net zero energy buildings. And we'll talk a little bit about some of the different definitions of what net zero might be, and happy to have a bit of a dialogue about that because I know that there are a number of definitions and they're important. And even New York State is looking to have a net zero energy building mandate probably for new construction residential by 2025. And we'll probably need to work hard to make sure that definition makes sense because there's a lot of definitions that I think make less sense. So my company is a design build firm. I'm a mechanical engineer by training, and we've got folks that do the design and the installation. We've got 3 installation crews. And we do mostly residential systems. We do some small commercial, and we get involved in the repair of larger systems that typically are, like schools and things that were a design, bid, build that didn't actually have all those pieces fit together just right. So we get pulled in on those as well. We also have a partner company that has 7 hydrogeologists. So we've got both the mechanical engineering, the geology, and the installation crews. So let's talk a little bit about kind of what's happening in the world. And I know whenever you come to a group like this, a number of you follow this kind of thing, and there might even be some details about some of these things you know more about than I do. But if we look around the world, we've got big things happening in terms of reactions or preventions of climate change, and then also trying to build up green jobs and things like that around some of those initiatives. The Paris Agreement is a big deal. Obviously, in this country, it's somewhat at risk, but we'll see how that goes. But it does give you an indication that the world is trying to make a shift. Germany has some regulations. One of the second one there is that one of their legal bodies is proposing a ban on, and ICE there is internal combustion vehicles, and so they're basically internal combustion engine vehicles they're looking to maybe ban within some reasonable amount of time in Germany. So I think Tesla showed them the way that you don't have to compromise all of what you want. California is certainly an interesting one. Their Proposition 39, it's a net zero energy in residential in 2020 and 2030 for commercial. And that's soon. And in Santa Monica, it's this year. Now, their definition leaves a little bit to be desired. There's still the ability to put combustion in and ways to offset it. But it does give you an indication that somebody's taking this seriously. New York tends to follow California in these types of initiatives. So I think it's something that we need to look at. Vancouver, in Denmark, you can't put a fossil fuel heating source. If let's say your oil burner craps out, you either need to switch to biomass or you need to use a heat pump already. In retrofit and new construction, you can't put a fossil fuel burning source in Denmark. This isn't fantasy. This is happening. The Army has always had this thing over the last several years about trying to do heat pump oriented systems and sustainable systems. Renewable energy credits are showing up in this area for thermal RECs instead of just solar RECs, so ways to compensate for renewables. Specifically in New York, a lot has happened recently. Governor Cuomo just came out with a $15 million 2-year rebate program for geothermal systems. It's a per ton, which is a capacity incentive, so it's $1,500 per ton for residential systems with a cap of $10,000. And commercial systems, it's $1,200 per ton with a cap of $500,000. And $500,000 is a lot of money. NYSERDA's just put out a renewable heating and cooling policy framework, and so they've set the groundwork for more incentive programs. So this governor's program is really almost a stopgap program. There will be more programs coming out. And renewable heating and cooling encompasses ground source heat pumps, air source heat pumps, and solar thermal. Ground source heat pumps is kind of the darling of that, mostly because of the beneficial effect that it has on the electrical grid. But those other technologies are also important. Solar thermal still has a federal tax credit and a state tax credit, so they're not exactly getting left out. Air source heat pumps and ground source heat pumps for a long time have been eligible for the Home Performance with Energy Star program to get low interest loans, up to $25,000 for a lot of households, $13,000 for others. The Green Bank of New York, which is essentially just a way for New York to participate and help the capital markets bring money into green technologies. They want to establish a fund to help finance retrofits of geothermal systems. A Renewable Thermal Alliance has been created. And you see all the states there. It's really New England and Massachusetts. I think New Jersey might join as well. And it's really a way for the groups like NYSERDA to team up with Massachusetts and Maine, New Hampshire, and Connecticut and share information and to try to accelerate policies that'll help bring these technologies to fruition. New York City has a geothermal bill for all city-owned buildings. Before they change out their heating system, need to basically do a study to see if they can make geothermal technology economically viable. And God knows that is tough. Because in New York City, there's not a whole lot of space. So for instance, St. Patrick's Cathedral, which is switching to geothermal, which is a big structure downtown, they have boreholes that go a couple thousand feet below the surface to try to get enough thermal energy to make it work. And skyscrapers are just that much worse. But it's interesting. And really, I think in New York City, what will happen is we'll find a way to share energy between buildings. So if one has a server room or is doing a lot of cooling and it's giving off heat and the building across the street needs heat, we're going to find a way that is like geothermal, but it's really kind of a sharing of resources, not necessarily within a single building, but across the street. It's called a heat map. They're doing it in London as well. There's a couple other things. I want to just keep things moving here. So the reason it's getting so much attention, and I'm going to have a little more focus on ground source heat pumps, but it relates a lot to air source heat pumps too, is that there's a kind of a unique combination of things that allows heat pumps to fit well with the goals of the state. It's the least greenhouse gases for heating and cooling. We have a relatively clean grid, and if we use renewables, then we can make a net zero argument. We reduce summer peak demand, and that's the biggest pain point for our utilities and for our infrastructure right now, because we're putting that thermal energy into the relatively accepting ground rather than trying to get it so hot that it goes into hot air, which uses much more electricity on those really hot days. There's a number of other things here too, but when we go and we talk to the Public Service Commission or the Governor's Office, this is the kind of information. This isn't necessarily what a homeowner values, but this gives you some indication of why the state may want to incent more activity in technology areas. So what is net zero? Well, net zero could be a bunch of stuff. They even have net zero ready, and it's an official program, I think, from the federal government. Yep. So you basically, you build it a little bit better than code, and then you make it PV solar ready is kind of the quick math on that. There's other elements to it. Has anyone been involved in net zero ready stuff at all? It seems like it's kind of a no-brainer to do, but it also doesn't get you there. Net zero on cost, I know there's a lot of times when I hear someone say that they got enough PV to be net zero, and really all they did is net out their electric use, but they still burn 1,200 gallons of oil or something like that. Where I think our net zero definitions need to be broader, encompassing really all the energy. Net zero on emissions, that's starting to make a little bit more sense, but still net means in many cases that you could produce emissions as long as you produce enough renewable energy that doesn't have emissions to account for other sources that might have emissions. So there's still a little bit of funny math going on in those definitions. There is a thought at one time to really have it be site-oriented. I think we're getting away from that because now we're seeing more community solar and ways to get renewable resources to a site, even if it is an on-site. And obviously in a more urban area, that is really the only thing that's practical. I was involved in a Solarize program. Imagine some of you have been at different times or know about it. Something like 70% of the people that were interested really didn't qualify because their house faced the wrong way, or they had a strange dormer arrangement, or their roof wasn't the right age, or they had a slate roof, or they were in a historic district. I mean, there's lots of reasons. But we shouldn't have those people shut out from getting renewable electricity. So the community solar idea, if we could get it to work, certainly brings a lot of possibility. So let's talk a little bit about the state's goals. So the state in the 2015 Energy Plan has goals set by the governor's office, and there's 2030 goals and 2050 goals. We'll just look at 2030 really for now. A 40% reduction in greenhouse gases relative to 1990 levels. That's pretty aggressive. That is going to be really challenging to do right now, especially since the second point there, the 50% of our electric generation needs to come from renewable sources. I'll show you in a minute why it's funny that we focus on that so much. Not that that isn't important, but it won't get us anywhere near that 40%, which I'll show you. And then we're supposed to reduce consumption in buildings. And depending on your definition of consumption, heat pumps, both air source and ground source, will help us reduce the greenhouse gas emissions because we'll get combustion out of buildings. And then your source, the building needs less energy if it's taking energy from the ground around it or from the air around it. And depending on your definition, it can help with, it needs less consumption because it has more on-site consumption, so it can also fit that other one. The 50% goal, like I say, is always interesting to me, that most people think of renewable energy solely as the production of renewable electricity. But if we did that, we would end up missing a big opportunity. So you'll see on this is the greenhouse gas inventory that New York State puts out. It was done a couple of years ago. And you'll see that 21% of the carbon emissions in the state come from power plants, so from producing electricity. 31% from homes and buildings, that's mostly heating and hot water. And then transportation is 34%, and then we have a couple of others. Those others are certainly significant, but they're the others. So if we reduce greenhouse gases by 50%, if our renewables go to 50% on power plants, that's really going to take that 21%, say, to 10% or so. We won't get close to a 40% reduction, so we have to address these other areas. We have to address combustion in buildings and transportation. Transportation is not my bag. We're not going to talk about how to do that. But homes and buildings, pretty straightforward what we need to do. It's just a question of can we respond quickly enough? So if we have that greenhouse gas inventory and 21%, if all the electricity we currently use magically went to renewables, 80% of our greenhouse gases would still exist. That's what that slide says. So we need to somehow deal with the homes and buildings. And if we look at that, and there's lots of different charts like this that we've seen at different times, water heating and space cooling account for the majority of that pie, which makes sense, especially in this area. Space heating can be very significant. So that is really what we're going to address here. So we're going to go after the big pieces of that pie that contribute the most to that very large slice of the greenhouse gases. Now, there's a few different ways to approach that. If you look at the passive house model, what we're going to do is we're going to say, and there's a couple of houses here, and I stole this from One Sky Homes, apparently. If I have a house and it's 3,000 square feet, which we see in the one that's closest to me, and those are kind of how the energies go in that house. If we go more to a passive design, and it's actually a larger house that they model, you'll see that the requirement for energy is radically lower. Now, if the requirement is radically lower, then our need for any kind of energy, renewable or otherwise, will be radically less. So I never underestimate the importance of the building envelope as really a fundamental step, especially new construction. We get such a great bite at the apple there, and it's tough to fix on retrofits as much. Not that that's not important, but let's build it right the first time. Let's need less energy, and then that makes everything else more practical. So the building envelope really is the main thing that we need to start with, and we need, even on retrofit, we need to address that where we can. Certainly putting in a very large heat pump system in a super leaky house is of questionable merit. You really, and there's many times where we did a bank in Corinth, and it was like a fishbowl. It was single pane glass and lots of it, like more than a third of the outer wall was single pane glass. And then it had a ring of single pane glass all along the top. you may have seen some of these banks. They look like they should be in Florida or something, but they built them here anyway. And so we looked at the heat load on that, and it would be like a 50-ton load in this relatively small, which is a pretty big load for a little branch bank. And so we said, hey, why don't we put more money into the building envelope? Let's double pane some of the glass. Let's panel in some of this fishbowl because it's just too much. And let's panel in a whole perimeter, which had awnings over it anyway. They got very little light benefit from it. But it was just a crazy arrangement. And so we basically had the same amount of money expended, but everything got better and everything got smaller. So the geothermal system ended up being significantly lower. I think we were down to about half the tonnage that we originally intended to put in. It was an electric resistance. It had a rooftop air conditioner with electric resistance coils as its heating source. So it was a big win for everybody in that. But we have to look at that building envelope. We have to really make it better. I do think, too, I see in more of ours that we're going to, the windows are so much better. And again, and as was mentioned before, if we're not sealing them, if they're not flashed in right, a great window, we can just sneak right around it. But windows now have become, if I go from really what is the equivalent of an R2 to anything close to an R6 or an R7, it makes a big difference in the comfort in that space. And it gives us a lot more flexibility in the distribution system for the HVAC. We're a little less dependent on having to wash all the windows aggressively because they're not as cold as they used to be, and we can have less ductwork and we can go from other places. So something that I really like. A building block is certainly an all-electric infrastructure. If we get to an all, and that's kind of where the net zero ready kind of thing comes from. If we can get an all-electric infrastructure in there in terms of our appliances, our HVAC and hot water, then if we get renewable electricity, then sort of just add water, we have net zero. You certainly can, we've been involved in projects that have, I don't know, it's a single family home, 5,000 square feet, they've got 30 kW of solar. It isn't necessarily all done beautifully efficient, but everything is electric. So it meets net zero. That's probably better than a sharp stick in the eye, but I think we need to do better than that. I always encourage people to really make the home the size that they need and then insulate it beautifully, rather than a big home that isn't as well insulated and then throw all the extra resource into a PV system to just offset something that really isn't terribly energy efficient to start with. Renewable electricity is critically important, so I didn't mean to diminish it when I said it. It's just, if we focus on that alone, we just don't get to our goal. So it's a pretty simple concept, really, is that we have an HVAC and water heating system that uses the least amount of electricity to accomplish those things, and then we offset it with renewable electricity, often PV, and then the net metering allows us to make that all work, of course. So we make more of our electricity when the sun shines and we've got long days, and we use most of the electricity actually in the cold, dark days of the winter. There's lots of different versions of this that we start to see. This is a GE version that came out a little while ago about some of the different things that we're going to see in the future net zero energy home. And all of these things exist in one form or another right now. They just often aren't all combined. It's kind of funny that the geothermal heat pump system also has an outdoor condenser attached to it. So it's always funny when the artist doesn't understand the technologies fully. This is from Efficiency, Vermont. And there's a lot of different elements I show here, but they're really those three. It's the building envelope, there's an electric infrastructure, and then we need to have some kind of renewable electricity to sort of tie it all up in a net zero package. So there's a few different types of heat pumps that we work with. Geothermal heat pumps are water-to-air heat pumps, so the water is the source that comes from the ground, that we're using water often as a transfer fluid, and then it's distributed through the air, which is a refrigerant heat exchanger. Water-to-water means that the source water comes in, and then we're also heating or cooling water out to the space, the load side. Air source heat pumps, I have a mini split system there, but there's also central air source heat pump systems. They're going to have a condenser, which then converts to an evaporator in the winter outside, and then they're going to have some other unit inside, or maybe multiple, like in the case of a multi-head mini split system. Air source heat pumps also are air to water. So the one in the top over there in the top far corner uses the thermal energy outside to produce hot water, which then is distributed inside, say through a radiant floor system or radiant panels. An air source heat pump is also one of these heat pump water heaters. It's just taking the air from the basement, taking the thermal energy from that and putting it into the water. It makes the basement a little bit colder, does a little dehumidification, which can be nice in some cases, but definitely something you have to think about where you place those things. They're also a little loud, so, but they are keys to getting you to net zero if that's a goal. Lots of distribution systems that do work and a bunch that don't work as well. Generally speaking, heat pumps produce lower temperature heat than furnaces or boilers. We're not burning something. We're just compressing refrigerant enough to get it to a temperature that we can do something interesting. So you can heat up water in either an air-to-water or water-to-water heat pump system and put it through a very high surface area radiator, which is sometimes called a radiant panel. High efficiency baseboard, instead of just a single tube with fins on it, you can have more surface area, so often double, and you'll see right there in the corner, you've got more fin area so that you can afford a lower temperature water for a larger BTU output. And we convert some single tube baseboard into higher efficiency so it can handle heat pump temperatures. Radiant floors are nice, big surface area, as long as they're either in slab or above the subfloor. Under the subfloor is not that friendly to, so staple up kinds of systems are less friendly to heat pump systems because we don't have the output, or we end up running in a less efficient, higher temperature mode. That's also true for combustion systems. If I have a condensing boiler, I'm not condensing in that boiler if I'm anything above 140 degrees anyway, and I'm starting to fall on a hairy edge. So even if any system that has low temperature hydronics will operate more efficiently than one that has that nice big surface area. Ductless systems can be both for geothermal and air source. There's versions of those. Often if it was a ductless mini split, that's a refrigerant head there. That's either hot or cold, depending on the season. If it was a geothermal, it's usually a water-to-water where we're sending either hot or cold water to that system. Geothermal systems tend to be central air systems is the most common. I'd say maybe 20% or less of our systems are a water-based system where the distribution system is water. It's more often a full set of ductwork. And the advantage of that is that you can heat and cool centrally. And in the Albany area where we're from, that's really most of the single-family homes are centrally ducted air systems, and we can heat and cool with the same distribution system. We have some no-budget projects, as I call them, and they use a radiant floor to heat, and then they have an air distribution system separately for air conditioning. And we just make cold water and send it to an air handler. So that air handler we'd send cold water instead of diverting it to the floor, we'd divert it over cold water over to the air handler. But you've duplicated your distribution system. And that's not a geothermal or a heat pump thing. That would be true of someone that wanted to use a boiler and also have air conditioning. You're going to have duplicate systems and duplicate distribution. So how do we do the hot water? There's a few different ways. Certain definitions of net zero would have you just using your conventional hot water heater. You know, could be propane, could be natural gas. I think that's kind of cheating, but you can do it if you can produce enough renewables to overcome that, again, based on some definitions. Air source heat pump water heaters, which is the GE GeoSpring that you see there, and there's some other versions of those. Those can work well, but you have to be careful because they're going to make that space cold and they're going to make some noise. Desuperheaters, so the geothermal systems oftentimes have the ability to donate when they're heating or cooling to the hot water heater so that they assist in that. It does decrease the space output, so you have to be a little careful. You have to make sure you size it properly to take on that extra source. Water to water or combination systems. So so for domestic water, you can go right at it with either water to water or water to air systems, kind of like the Space Pack has that system for hydronic heating, but you can also use it for domestic hot water. We've done a bunch of solar thermal and solar thermal hybrids. I don't do them as much anymore because it tends to add complication to the system, especially with the de-superheater that works well in most of our systems. But I know lots about that if people have questions about it. So how does this all work? It got more challenging over the last few years. So this is from NYSERDA, and that's the price per gallon for heating fuel, and you'll see that it went up $1 every year. So it went down $1 every year. So if I'm doing math on what's the cost effectiveness of switching from a combustion system to an electric-based system, if it's $4.12 a gallon, that's very different math than if it's $2.12. So that's added lots of complication. As much as the state wants to get away from combustion systems, it's hard to get it to pencil out. Now, this is a Massachusetts study, but it's very similar to New York, and I've got the resource there. But you'll see this is a typical heating bills for sort of normalized houses. And there's assumptions behind here about the price of different fuels. But this is kind of what we see in our area too. Oil and propane are probably a little switched right now. Propane is a little bit lower in price because it comes mostly from natural gas, and natural gas is quite low. Oil is probably a little higher, but they're both kind of in that range. They're considerably higher than natural gas. Ground source heat pumps are usually compatible with natural gas on a money basis. So if I replace someone's natural gas system and they spent $1,000 on natural gas, they'll spend $1,000 on electricity to run it, which is good, except for it's not good enough usually because the ground source heat pump system will cost more. So if you don't have savings, that's tough. You've got electric air source heat pumps, and there's lots of information about that. We install and monitor those as well, and I am very curious about NetZero Village and trying to get data from there, which we talked about some, is just to see how they really perform. They use about twice as much energy as a ground source system seasonally if you compare like technologies. So if you have a variable speed ground source and you have variable speed air source, the ground source is usually about half the amount of electricity in the winter, and it's about half the amount of electricity in the summer, and in particular at the peak, which is the most important thing to the state. Now, there's some interesting things happening right now where the Public Service Commission is talking about trying to set a reduced rate for geothermal systems, and that reduced rate would be maybe as much as half of the cost of electricity for the geothermal portion of your house. So if whatever additional electricity was added, so what does that do? Well, in this case, that 700 would go to like 350. So now you've really got a better case because now you're significantly lower than natural gas and a number of other technologies. It would encourage the ground source systems, which would reduce peak in the summer and would minimize the growing peak that we'll get in the wintertime. But right now, the utilities would love to sell more electricity in the winter, most of them. It's always kind of interesting with a group like this. So this is pounds of CO2 per therm. And so these are all, so a therm is 100,000 BTUs. So to produce 100,000 BTUs of heat energy to a building, this is how much. You'll see geothermal relative to natural gas is about half. So remember, they were about cost neutral, but the geothermal system using the basic sort of average carbon of a kilowatt hour in New York State would be significantly less. We have a nice clean grid. Now, if this was in central Pennsylvania or something like that, that's a different story, even though it would operate exactly the same. It depends how clean your grid is. If you do go net zero, you can net those out. You can even net an air source heat pump out. You'll see if you use all electric, like a baseboard or a toaster or opening your oven, that's going to actually have not a very nice effect for carbon or cost. And an air source heat pump is about half the cost of electric baseboard, and a ground source is about half that of air source. And since they're all electric, the carbon values basically scale the same way. Oh my gosh. We have a big conference coming up. So Ken Daly is the president of National Grid, and so he's coming to the geothermal conference in April, which is a great sign because we need to get the utilities on board. Paul Tonko's going to come. He's always great to have around. Good rallying cries. And John Rhodes, the CEO of NYSERDA. So there's a big interest in trying to address this sector. If you want to do something, and it's simple to do, There's 3 different environmental groups that have started renewableheatnow.org, and honestly, they're not quite sure what they're going to do yet, but they want to try and get combustion out of buildings. And so if you want to get on that mailing list and find out about their activities, just jump on there sometime. So that is the end of my prepared remarks.